In this modern world, our digital clocks tend to keep very good time, or they tend not to work at all. But back in the day, we used wind-up clocks, and wind-up clocks often ran a little fast or a little slow. And at the end of the day, they wouldn't have the correct time. But if we knew whether they ran fast or slow, we could make guesses as to what the correct time was. And then the next day, we'd reset them and start over. Well, Dr. Nefario still has a wind-up clock in his laboratory, and he set it one day at 6:30 a.m., and then when he came back a few hours later, it said 9:45, and he thought he wouldn't know what the correct time was because he didn't know when it had stopped. But a minion stepped up and told him it had stopped exactly 2 hours and 35 minutes ago. So Dr. Nefario then knew the correct time. Well, there's several ways to solve this problem, but we're going to use ratio and proportion. The clue in the problem was that in real time, an hour, his clock only runs for 45 minutes. Well, an hour is 60 minutes, so we get the ratio shown. And then we know that from 6:30 to 9:45 on his clock is 3 hours and 15 minutes, or 195 minutes. Now we set a proportion. 60 minutes in real time is to 45 minutes on the clock, as the unknown number of minutes in real time is to the 195 minutes on his clock. And if you know anything about proportions, you solve it like this, called cross-multiplying, or more formally, the means extremes property. And if you do the arithmetic, here's the answer, 260. We remind ourselves that that's 260 minutes, which then translates to 4 hours and 20 minutes. So we add that to the 6:30 a.m. from the real time, and we realize that when the clock said 9:45, it was actually 10:50. Then we recall that the minion said that the clock had stopped exactly 2 hours and 35 minutes ago. So 10:50 plus 2 hours and 35 minutes? No, it's not 12:12 on December 12. It's 1:25 p.m. The answer to this week's problem of the week.